Good morning, all. Let us begin with tree traversals today. Okay, let me share the screen quickly. I'll first go through the PPT and we will have the related program. Okay, whether the screen is visible properly. Voice is breaking. Okay, let me switch off the video. Okay, now my voice is clear. Yes, whether my voice is clear now. Okay, thank you. Okay. So, as discussed in the previous class, there are three ways or three different traversal techniques available in a tree. I call them as in order, pre-order, and post-order. I think yesterday I did mention about one of the tree traversal technique called as in order traversal. This is where I stopped, and I had given you an example to try on your own. Okay, has anyone tried it? Has anyone tried it? Please let me know from your end. Okay. So today I'll be taking one more example for each of them in order, pre-order and post-order. And then I'll be going through the program related or the function related to each of them. Okay. Then we will go through what is called as how do we display the tree in the tree format. Okay, this is what I'll be discussing for today's class. So let's begin with what is called as in-order traversal. In-order traversal talks about recursive calling of one side of the tree. Until and unless the left side is over, I will not go to the root of it. Okay. So every time traverse till the leftmost part. Once that is done, then visit the root. Then do the same thing on the right side until you reach the rightmost node. This kind of iteration, this kind of looping, it requires what is called as recursion. Okay, I hope you remember we had something called as recursion in stack. Okay, we had seen that. So the same recursion is becoming very much handy in managing all the tree related functions. Okay. So when I take up in order traversal, you can remember it like this. Let me take a pen. Okay. You can remember the in order traversal like this: left, root, right. Okay. And I will be writing RI for right. Root I'll be writing R. Don't get confused. Okay. So you can remember the in order traversal like this: left, root and right. According to that, if I consider the following diagram, okay, this is a tree, an example for the tree. You can just see I have numbered the order in which the part of the tree has to be taken care. I have numbered them. Okay, you can just see. For A, which is the root node, which is the root node of the tree, quickly comment guys. Okay, I require a lot of interaction from your end. Okay, A is the root node. Now at the A, when I start applying in order traversal, A, can I call this as the leftmost node? No. When can I call any node as leftmost node? If its left part is null. I'll repeat again. When do you call it as a leftmost node? Whenever the left part of the node at which I am checking is null. Until that time, I do not call it as a left node. But if the left part of that particular node is null, then I call it as leftmost node. Okay. So now when I consider A, I apply in order traversaling. First thing that I come across is visit the left subtree. So A's left subtree, it is taken care. Definitely A is not the person to be visited first. So what it does, it just pushes to the left hand side. On the left hand side, there is B. Whether B's left is null? Not yet. So again, it is pushed to the left part of B. Who is there in the left part of B? D. D's left part is checked. It is null. Okay, D's left part is null. So what happens? I will just return back telling that you are the leftmost node. So I will go on until the leftmost node is reached. How? Until the left part is null. So every time how the things are taken care. In case of recursion, actually the root is getting overwritten every time. Root is getting overwritten every time. Does it mean that you are overwriting the overall root? No. Every time the recursively the function called, the function is called with the new recursion or with the new root. I will call something like this. What I will do is, I'll write in order of, let me write it in short, okay, in order of A arrow left. In order of A arrow left. What is the meaning of A arrow left? When I write A arrow left, it is nothing but B. Okay, so it comes here. This again calls in order of B arrow left. Okay, it calls again in order of B arrow left. Just 1 minute, guys. Hello, Ankit. Yes, tell me. You have class up to 11? Oh my God. Then 1 minute. Then I have started my third semester class, dear. तो क्या कर सकते हैं? 10 o'clock ले सकती हूँ मैं soon after this class. ठीक है? ठीक है. Okay. Let me know. ठीक है? Okay. Now what happens? It takes B arrow left. Okay. There is a call for B arrow left. What is the meaning of this? Every time the new route is taken. Every time recursively the new route is taken. So it goes into B arrow left. What is there in B arrow left? D. So it again calls in order of D arrow left. Are you getting this? There is a call for the same function again and again on different route. Who is the root now? Now the root is D. Okay. So once this is done, it goes to the left part of D. D's left is null. So what I will do, base case, I will take like this. Base case, if root is null. If root is null, I will simply return. If root is null, I'll simply return. So every time there is a function call until the root has returned a null. Okay. So at this point, D is left definitely would be a null. So null returns what? Returns the context back to D. It doesn't do anything. It simply tells I'm done with the left hand side. I'm just returning the context to you, back to you. So who will receive back? The call for in order of null arrow left, it will just call for a return because root is null there. Once it has come back, it has completed the left hand side checking of D. Left hand side checking of D. So it has come back. Next what? Visit the root. Guys, you have to pay attention, only then you will understand this. Okay. I am repeating this again. Please pay attention. So I will repeat again. How the things are taking care. A's left is called. A's left has B, which is taken as a new root for the next function call, recursive call. So in order of B arrow left. Again this goes into D. Now who is the root? D is the root. Now what happens? D's left is called. In order of D's left. Every time it goes on until it reaches a null. So D's left is null. Whenever it reaches null, it has to just return back. Where it has to return back? It has to return back to its parent. Who is the parent? D. Returns back without doing anything. Now, D has completed traversing left subtree. With reference to D, I'm talking. With reference to D, the traversing of its left tree is done. Next what? Visit the root. It means what? Print that particular node. Who is the root node? Root node right now is D. So print it. Then traverse the right subtree. D is right. Next is what? In order of D arrow right. In order of D arrow right. What is there on D or D arrow right? Can anybody tell me what will be the root next time if I call in order of D arrow right? What will be the root? Null. So whenever the root has become null, what happens? It simply returns back without doing anything. Without doing anything. Please pay attention. In this part, I have visited the left. I have printed the root. I have visited the right. This subtree has been done. It has been done. So what it does? It simply returns back. All the three steps are done, so it returns back. Where it has come back? It has come back to its root. So which call it is? This function call. It has come back to this function call. So with reference to B, what has been done? What has been accomplished? Visiting of left subtree is done. With reference to B, visiting of left subtree is done. Okay? Visiting of left subtree is done. Then what happens on the right side of B will be taken. What is the meaning of that? In order of B arrow right. In order of B arrow right, when I write, okay, when I write B is right, what is there on the B right of B? It is capital E. Okay, so this is again taken as root. Again it is taken as root. Its left is checked. It is null, returns back. Then it's right, then it is visited. Okay, visit means printed. So what has been printed by, till now? D has been printed, B has been printed. Now it has come to the right. On the right side, left hand side is already null, so it has returned back. It prints E next because traverse left subtree and then visit the root. Whenever I tell visit, you have to print it. Okay, then it goes on the right hand side. Okay, on the right hand side, already the right part of E is null. So what happens? Simply it returns back. With reference to E, visiting the left, visiting the root, visiting the right, all the three are being done. So I am done with now D, B and E. What is this D, B and E? D, B and E, they constitute the nodes present in the left subtree of which node? Can anybody quickly comment? Left subtree of which node? It is A. So now the left subtree of A has been done. It means what? Traverse the left subtree with reference to A. It is done. Next step for A is what? For every node you have to have three things. For every node you have to have three things. What is that? Traverse the left, visit the root, traverse the right. This is for in order. Okay. Now with reference to A, traverse the left is done. Next what? Visit the root. It means what? Print A. Then traverse the right. When I tell traverse the right, again I should apply left, root and right. So now the new root node is C. On the right side, the new root node is C. C is left. Can I visit C immediately? No. Until and unless left becomes null, I cannot visit that particular node. Instead, what it does? It just postpones it. How? It calls in order of C arrow left. What is there in C arrow left? F. Okay. Now, F again checks on its left side. Null. It returns back. So, visit F. Who is the next person to be visited? Look at the way the printing has been happened. D is the first person, then B, then E, then A. Now the next turn is F. Okay. Then F's right. F's right is null. Simply it returns back. F is done with left, itself and right. So this whole subtree is done. Returns back to its caller. Who is the caller? In order of C. C arrow left was called. Okay. So it has come back to the root. With reference to C, it has been done with visiting of left. Now it has to do its own visiting, means the next node to be printed is C. Then go on the right hand side. On the right hand side, G is there. It again checks its left, null, comes back. So print G, goes to the right, null, comes back, returns back to C, then C returns back to A returns back to main. This is how the things are taken care in case of in order traversal. Okay, please tell me, have you understood this point or you want me to tell it again? You may ask me to repeat this 100 times, I don't mind. But you just have to understand this very thoroughly. Once you understand in order, pre-order and post-order will follow accordingly. Please let me know from your end, have you understood this? Be frank enough, don't hesitate. You have understood it. Oh, very nice. On one go, you have understood it. Hats off to myself. Okay, so if I take up now, what will be the in order traversal for the tree? Can you quickly comment on this? I have actually numbered them. Okay, I have actually numbered them. It becomes so easy for you to understand it. Okay, let me check. How many of you have commented? Let me check. Please understand and write. Simply don't copy. Okay. Yes, let me check it. Let's go. Okay. I'll take a pen and let us have a revisiting of the nodes. Starts from A. A is the root node. Left is empty. No, it goes on to the left. B. B becomes a new root node. Whether left is empty? Not yet. Not yet. So what happens? It visits the left tree again. D is the left node now. It checks on its left. D is left. Null. Returns back. So D gets printed. Which is the first element to be printed? D. Then left side of B is done. Returns back to B. B gets printed. Then it goes on to the right side. Right side E is there. E checks its left. Null. Returns back. So prints E. Okay. Then right null. So returns back. E is done with all the three things. Left, itself and right. So returns back to B. B is done with left, itself and right. So returns back to A. Now A has done the left subtree. So it prints itself. Okay. Then goes on to the right side. On to the right side, C is the new root node. With reference to C, now it checks its left subtree. Left subtree, F is there. F's left is null. So returns back. F prints itself because it being the root node, left is done. Right of F is null, returns back. Then once F has done its part, returns back to C. Now C being the root, its left subtree is traversed, so it prints itself. Then goes on to the right side. G is left, null, so G gets printed. Then G's right is also null, returns back to C. Then C returns back to A returns back to main. So D, B, E, A, F, C, G is the in order. Okay, let me check how many of you have answered the same thing. Okay, very good. All of you have answered correctly. Very nice. So let us check the answer. Yes, D, B, E, A, F, C, G is the in order traversal. Now the next two things you have to answer to me. Okay, guys, I will not explain that. I will just tell you the preamble of pre-order and post-order. Okay, pre-order tells visit the root. First root, then go to left, then go to right. Okay, now with reference to this tree, what will be the pre-order traversal? You take your own time. I'll give you 1 minute of time. What will be the pre-order? Okay, let me check what you have answered is correct or not. Okay, let me check. Now visit the route. So whoever is the route, print it. Don't bother about it. Pre-order. Route's position is prior to left and right. That's why it is pre-order. A. Then A's left is B. It being the root node gets printed. Okay. Then go to the left. D being the root gets printed. Now it checks for left. Left is null, returns back. Right, null, returns back. So left itself and right are done. Next, returns back to B. Itself, B has been printed already. Left is done. Now it is E. Okay. Then the left subtree of A is done. Returns back. A has been printed already. It goes to the right side. On the right side, C being the root node gets printed. Then goes to the left. Left is F. F being the root node gets printed. Then left and right are checked. Both are null. Returns back. Then goes to G. G gets printed and it returns back to C. C returns back to A. A returns back to the main. Okay, let us check your answers. Ramya, I'll take 10 o'clock class. Okay, yeah. Okay. Otherwise, I would have taken your class now. Okay, let it be. Okay? Now I'm taking third sem class. That's fine. Okay. Yes. A, B, D, E, F, C, G. Is it FCG or CFG? CFG it is. Okay. So let us check the answer whether it is correct or not. A, B, D, E, C, F, G. This is pre-order traversal. So can you do the post-order traversal for the tree in just half a minute of time? Same tree you have to take. Numbering will be different. Please note, numbering will be different. I will tell you traverse left subtree, traverse right subtree and visit the root. Okay. Left, right, root. That is your post-order traversal. Left, right and root. Root will be the last. Okay, okay. You're answering, but let us check your answer. Shall we check for the answer? Okay, you can just see. Left, right and root. Okay. A being the root cannot be taken. Goes to the left. B being the root goes to the left. So D becomes the first node to be visited because both the left and right subtree are null. So D gets printed. Then left is done. Returns back. Then B's right is called. What is B's right? E. E being the leaf node, it gets printed and returns back to B. Next, root gets visited. Left subtree is done, returns back to A. A calls the right subtree. On the right subtree, C being the root, calls left. So F, then right, that is G, then the root, then comes back, then the root again. So D, E, B, F, G, C, A. If you take every time the subtree in order, B will be in between D and E. Over here, C will be in between F and G in order. In case of pre-order, B will be the first element, then D and E. Here C, F, G. In case of post order, left, right and root. So it will be D, E, B and here F, G, C. Okay. And A in order will be in between B, D and E and F, C, C, F, G. Okay. In pre-order, A will be the first node. In post-order, A will be the last node. Are you all getting this or any doubt you have? I hope you are getting this. Please let me know from your end. Are you all getting this? Okay. Okay. So nice then. Then let me give you one more example. Can you try all the three on your own? Okay. Within a matter of 1 minute, you just have to tell me what is the answer for in order, pre-order and post-order. Okay. Quickly guys. So let's say I have 10 here, 20, 30, 40, 50, 60, 70 and finally 80. Okay, you have to write in order, pre-order and post-order for this particular tree. I'll give you 1 minute of time. Don't panic, do it very thoroughly, slowly. Okay, done. Shall we do it? Okay, let's do it. If I take, do you want me to do in order first? Okay, let's do in order first. Yeah, in order must, matlab, root must be in between. Okay, let's go ahead. If I begin at 10, simplest thing that you need to do is, you have to go to the leftmost node of the tree for in order. Who is the leftmost node? 80. So I'll simply go to 80. Okay, 80 is the first node. Then left is done, root 40. Then right is null, so just returns back. Next I have 20. Next I have 50. Okay, next I have 10. Next I have 60. Next I have 30 and 70. So this is your answer for in order. Let me repeat again. 80, 40, 20, 50, 10, 60, 30 and 70. This is your answer for in order. Have you done it correctly? Please check it out. Okay, next, pre-order. Pre means root has to be the first. So obviously 10 becomes the first. Just go on writing the nodes as and when you visit them. Okay, 10, 20, 40 and 80. This is your first part. 10, 20, 40, 80. Okay, left side is done. 40's right side is null, returns back. 40 returns to 20, then 50. So 10, 20, 40, 80, 50, 30, 60, 70. This is your pre-order. I'll repeat again. 10, 20, 40, 80, 50, okay, 30, 60, 70. This is your pre-order. Post order, please cross verify. 80, 40, 50, 20. I'll repeat again. 80, 40, 50, 20, then 60, 70, 30 and 10. Have you done it correctly? Have you done it correctly? Check it out and please try them out. I think probably almost all of you have answered correctly. Okay. So good that you have understood so easily. I was just worried that if you can't understand it, should I take up the board and explain? How should I explain this? Because this requires a lot of involvement in order to understand it. And I'm very much thankful to you for understanding it so easily. Okay. So shall we go to the programming part of this? Yes, tell me, shall we go to the programming part of it? Okay, nice. You guys are so sweet. Yes. Let me just show you the simple in order traversal. Okay. We will go in the order in which we have discussed. In order. What is the meaning of this? Base condition. I am talking about a recursive function. Okay. As I have written the pseudocode, same way I am writing this. If at any point in time root is null, simply return. This is what is the base condition. Guys, if you miss this, what will happen? Can anybody tell me? If you miss this, what will happen? Can anybody tell me? If I miss this, what will happen? Any comments from your end? Okay, one answer I've got. It is infinite loop. 100% you are right. If I don't write this base condition, recursion will end up in what is called as infinite loop or infinite recursive calls. Okay. So as soon as at any point in time, whenever I reach a null, be it on the left hand side, be it on the right hand side, the things will happen to return what is called as return back to its parent. Do nothing other than returning back to its parent. This is the base condition holding good for all the three: in order, pre-order and post-order. Please do not afford to miss this condition. Recursion, when I was teaching in stack, also I mentioned the relevance of base condition. Okay, so base condition for this recursive in order, pre-order, post-order is this. Then what is the thing? According to the pseudocode or according to the steps that I had written in the PPT, similar to that, what I will do, I'll call in order on every time root arrow left. Every time the root getting changed. Are you actually changing the root's address? No, man. You are just overwriting in that particular function call. In that particular function call, the root gets overwritten. That is local. Once the scope of that particular function call ends, the root obviously will come back to the person who has called it. Okay, this is the beauty of recursion. That's why I'm asking you, have you understood this? Now, at this point, when I write in order of root arrow left, when I tell root arrow left, it is nothing but you are visiting the left subtree. And as soon as the left subtree is done, when it returns back to the caller, you are simply printing the roots info. You are simply printing the roots info. Next, what you are doing is you are calling roots right until you reach the roots, the rightmost node. This continues. So this is how the things are taken care. I think the steps I have explained it very thoroughly with the example. The steps that I have explained, I am just writing that as a code here. Nothing else other than that. Okay. So what can be pre-order traversal? Can anybody tell me quickly? What can be pre-order traversal? You can unmute and tell me how I can write pre-order function. Jaldi. Anyone is typing? Here I cannot know from your end if anyone is typing. It is better in WhatsApp. WhatsApp tells me who is typing. Okay. But this chat never tells me who is typing. I just have to wait until you press enter. Can anybody tell me how you can write? Okay. First print root, then left and then right. Wow, very nice. Who has commented it? Aryan and Ananya. Very nice. You are printing the roots info first, then you are calling the left, then you are calling the right. Wonderfully said. You are 100% right. You are right, Anushka. Very nice. Now, if I ask you to do the post order, what is the way you are doing? What is the way you are doing if it is post order? Okay, let me just show you the pre-order. Is it according to the thing that you have shown? Okay, this is your pre-order. As told by them, you are printing the route first, then visit the left, then traverse the right. Definitely the post order would be left, right, and then the route. So printing happens at the end. So this is the post order. Are you all getting this? Any doubt at this point? All of you are right. Good work done. Good work done. So can you please make sure that you are completing these functions by today? Please make sure that you are doing then and there only. Otherwise, it becomes so difficult for you to understand the things. Okay. Now, I just want to show something called as displaying the tree in the tree format. This is called as displaying of the tree in the tree format, similar to the things that we have discussed in order, pre-order or post order. Okay. Similar to that, you just can see the line number 91, it is indicating what? Indicating what? The base condition. At any point in time, if the root has become null, simply return back. Don't do anything. And when I call the display function, I'll assume that level of the tree is 1. I'll assume that level of the tree is 1. Actually, level of the tree will be beginning at 0. But when you are displaying, when you are calling the display function, pass the level as level of the root plus 1. I'll repeat again. Pass the level, initial level as level of the root plus 1. Okay, level of the root plus 1 is 1. Now, you can just see similar to the in order traversal or pre-order traversal or the post-order traversal, I have done here the reverse manner. Okay, this is called level order printing. I'll call it as level order printing. Please note it down for your reference. You have 4 categories of displaying of a tree. One is called as in order displaying or traversing of the tree in the in order. Second, pre-order traversal. Third, the post-order traversal. Fourth, I call it as display of the tree using level ordering. Okay, using level ordering. It means what? All the nodes at that particular level are getting printed. Then you will go to the next level. Then you will go to the next level. This is called as level order printing. And when you are doing level order printing, always I will begin from right, then I'll go to root, then I'll go to left. I'll repeat again. I'll start from right, then I'll go to the root, then I'll go to the left. Why this is the case? I will just draw a diagram for you and then you will understand it. See, whenever I'm displaying the tree using this level order printing, I always display the tree in the sidewards. What is the meaning of sidewards? The root will be at the beginning, then my left and right will be like this. This is my right child. This is my left child. Okay. Who is coming first there? Can anybody comment? Who is coming first? Is it the left child or the right child? Who is coming first? 3. 3 is what? Left or right? Right it is. See, if I show you the normal tree would look like this. It is looking something like this. Okay, this is my original tree. But when I'm trying to display using level order traversal, I always begin from the right. Top to bottom the printing happens. Guys, printing always happens from top to bottom on the screen. You cannot print 10 here and go back and print 3 on the line previous to 10. Always the printing begins from right to left, means top to bottom. It is actually rotating this tree in the anti-clockwise direction. You are rotating the tree in the anti-clockwise direction. That is when you get level order traversal. Okay. Now, when you're printing in this manner, the first node to be visited is right, then the root, then the left. And every time you're calling the next level. Is there any node in the next level? If so, print the rightmost, then go to the root, then the left. Are you getting this or not? Please let me know. Please let me know from your end. Guys, are you getting this? Only one is? What about others? Truly you are getting? Okay. Now I'll go back to the function that I have written. Right, root, left. According to that, I will go on until it has reached the final level. Okay. Now what happens? You just assume that, let me just draw a diagram for that. Okay, you just assume that. Let me take up the previous example. Okay. Yeah. Now, if this is the diagram, A, B, C, D, E, F, G. Okay. If I want to display them, I will actually do the anti-clockwise rotation of the whole tree. Okay. Anti-clockwise rotation, it means by 90 degrees. Everything gets rotated by 90 degrees. So, on the right side, how many times the things will be taken care? On right side, A is right, level plus 1. I have passed level as 1 initially. Level plus 1 is 2. A is right is C. C comma 2 will be passed. Then I will call display of C is right is G. G comma 3. Okay, G comma 3. So on its right side null is there. So it returns back. What is the level that has been taken care? 3 is the level. Okay, 3 is the level. And when I go back to the function, 3 is the level. I is equal to 0. I less than 3. I less than 3. I plus plus. Every time those many number of spaces are left. Those many number of spaces are left. So every time, every value of I am leaving 4 spaces. I'm leaving 4 spaces. It means what? On the, if this is the console, this is the first column. From first column, every time 4 spaces are left. So 4, 4 and 4. Totally 12 spaces are left before printing the rightmost node. Before printing the rightmost node. Who is the rightmost node? Rightmost node is G. 12 spaces are left and G gets printed. Then a new line is taken. A new line is taken. Then what happens? Root arrow left. Then goes to the left part. What is there in left part? Left part would start from the root itself. Who is the root? Who is the root right now? G is the root. Is there any left part? No. So this is how the things are taken care in the manner right, root, left. Right, root, left. Every time right, root, left will be taken. So G will be printed first, then they taken a new line, then C gets printed with only 8 spaces. With only 8 spaces. Why? Because level of C is 2. For one value of I, 4 spaces. So for I is equal to 2, 8 spaces will be left. Then it comes to left again. What is there in left? Left level is 3. Again 3 spaces are left. So 3 into 4, 12 spaces. So G printed, next line C printed with 8 spaces, next line F printed with 12 spaces. Next line, when it comes, level of A is 1. So does it give any spaces? No, because I less than level is there. Okay, I less than level is there. So A gets printed simply. Right is done, root. Then it goes to the left. On the left again, B is the right goes. So right gets printed with 12 spaces. Then new line. Then B gets printed with 8 spaces or 4 spaces. Don't get confused with the spaces, but this is how the things will be. Then the new line and the leftmost node gets printed on the sidewards. Okay, I'll just show you how it looks. Let me just go to the program and I'll show you how the things will be happening. Okay, run it. Quickly, you can just have a look at the thing that I am constructing right now. Okay, I'll insert the node. All of you write down the way I'm inserting. Please, all of you, do it. Okay, I'm inserting 10. So 10 is the root node. Okay, with the reference that I am mentioning right now, please do it. Please do it immediately. Then I will insert again. I'll insert again. Now I'll give 20 as the node to be inserted and direction I'll give as L. Okay. Left hand side 20 will come. Then I'll insert again. 30 is the node to be entered and now I'll give the right as the direction. So 10, 20, 30 are the nodes that are inserted. 10 is the root, 20 is the left, 30 is right. Okay. Now I'll enter the choice again. 40 is the node to be inserted. Okay. Left and left I'll give. It means 40 becomes the left child of 20. Insert again. 50 is the node to be inserted. Left and right I'll give. Insert again. 60 is the node to be inserted and I'll give right and left. Insert again. 70 is a node to be inserted and I'll give right and right. Insert it. Now I'll call 5. So how the nodes are displayed, you can just see in the anti-clockwise direction. 10 is the root node. Then 20 and 30 are the level 1 elements. Then all these are level 2 elements. How they are printed? Rightmost, then root, then left of the right subtree, then the main root, then on the left side, right, root and left. Are you getting this? That spaces, it is only for the look and feel, nothing else other than that. Okay, let me just have a look at the chat that Anushka has typed to me. Can we not print same tree? Ma'am, like horizontal way. Definitely you can. You just have to pay attention for giving the number of spaces. Okay. Similar to the looping under for loop while loop, you had done that printing of pyramid, printing of a triangle format, star printing. Okay, that patterns you had done. No, similar to that, you have to apply the number of spaces how you want to leave. Then you can definitely print the things in the tree manner. This is called level order printing. Any doubt you have? Please let me know. Yes, guys, any doubt you have? We'll run the code for pre-order, post-order. Okay, 1, 10 is the insertion, 1, 20, left, 1, 30, right, 1, 40, left, left, 1, 50, left, right, 1, 60, right, left, 1, 70, right, right. Okay, now I'll go for in order. You can just verify this. Okay, then I'll go for pre-order, then I'll go for post order, then I'll go for displaying. Okay, and then exit. So I'll be sharing this code to you today. Okay, you can just check it out and go through the things. Please be perfect with this. Okay, and in the next week I'll be beginning with what is called as binary search tree based on these inputs. Okay, homework for today. Homework for today. Take down. I'll be giving the array. You have to construct a binary tree. Write the in order, pre-order and post order for the tree. Okay, take down quickly. I'll stop sharing for a while. Okay, take down quickly. Arrays in the array order A, B, C, null, D, E, F, G, null, H. Construct pre-order, in order, construct the tree and then write pre-order, in order, post order. Can you do it for today? I'll be sharing the program to you in the classroom. Okay, and please go through the program, do it again with your hand. Okay, only then you'll understand it. So shall we end now?
Yes, ma'am.
Okay, thank you all.